Hi, welcome back to the Robocars podcast. I'm Brad Templeton from Robocars.com, and I'm here today with Tomas Ohlson, who is one of the founders and an engineer at Einride, an unusual Swedish company which is building self-driving trucks and remote-controlled trucks with the actual purpose of electrifying transportation in trucking, even more than automating it. They're interested in both of those, but their core focus is actually seeing what they can do about electrification, a problem that many people are working on. Now, we usually start this podcast by talking about, before we get into the subject matter of interest to the guest, we talk about some of the issues in the news. And I know you may or may not want to comment on, maybe not competitors, but other companies. But the big story of the last couple of weeks, actually, is an accident or crash. The word accident is sometimes looked down upon these days, involving Cruise, General Motors unit, which is making robotaxis in the city of San Francisco, where they had a very embarrassing low-speed crash, but against exactly the thing you shouldn't hit, the backside of a city bus. And this shocked a lot of people because Cruise had done about 1 million miles of operation with no safety driver in the vehicle. They had had a couple of incidents, but nothing too serious. But basically, and Cruise's own CEO said, there's just no way they should be hitting something like the back of a bus. The sensors all saw the back of the bus perfectly clearly. When they finally did state why the accident happened, it was an obscure situation with their predictor. And for those who work on self-driving cars, you know that prediction is actually one of the most important things you can do. In fact, perception is only there to help you figure out not what's happening now, because what's happening now is boring. It's what's going to happen in the future, which is what governs how you drive. And so all self-driving vehicles have a predictor, and it was trying to predict where this bus was going to go. This was an articulated or bendy bus, two-part bus. And they had basically a problem similar to trucking, actually, something towing a trailer in a sense. And they had put in a heuristic which said that we will consider the front of the bus to be important, and the back just follows the front, rather than trying to treat them as two independent vehicles. Not an unreasonable thing to do, but then that combined with another element of their system, which is that, of course, things pop in and out of existence in a perception, maybe even more than people would like to think about, but things get hidden. And in particular, the front of a bus can get hidden by the back of a bus. The front of the bus got hidden. Their predictor thus was just making predictions of it's going to keep driving the way it was before, but it was actually braking. And the back of the bus obviously showed it was braking, but they were tracking the front of the bus. They couldn't see it. They assumed it was continuing at the same speed. They assumed the back was following this invisible front and plowed right into it. Now, my criticism of this crash is not that bug, although obviously that was a pretty embarrassing bug, and I'm sure they regret the decisions that went into that piece of code. But something bigger, which is I don't think an accident like this should happen even if your prediction and perception systems are severely failing. It should always be the case that there are sanity checks that say, I know we're predicting this bus is going straight, but that prediction doesn't match what we see. And they didn't have that, and I hope they're going to soon do a better job of that. What do you feel about that, Deb? Hopefully you will tell me that your systems do have those sanity checks and shouldn't fall prey to this. They did fix the problem, but what I've asked them and they haven't answered is, have you fixed it to the extent that if you still made the wrong prediction about the bus, you wouldn't hit it this time? What do you think? Why did they have that kind of bug? Is it a sign of some problem there? Or is it a kind of problem that, nobody's totally immune from problems. But how you handle your problems is actually important. What are your feelings on this, Thomas?
I think foremost, autonomous driving is really, really, really hard, and especially in city traffic. So when you're in a diverse, complex environment like city traffic, there is, the predictors, as you say, becomes extra important because there's so many variables everywhere, and there's so many different situations that can appear, which makes it very, very tricky. And even if you've driven 1 million miles, So I'm super impressed by Cruise and what they've done and what they're doing. I think, like you're saying, like driving robotaxi fleets, it's a really hard problem. I think in our case, we want to approach something simpler to begin with, and we think that might be an easier way of going about this, which might not require the same level of a complexity understanding that you might need in city traffic. But with that said, hopefully the industry learns how to think about building engineering predictors and how to reason around these like sanity checks that you have to do, because sanity checks can make sense in one situation, but then suddenly you find yourself in a situation where that sanity check doesn't make sense and you haven't thought about it, and that makes it super hard. But I mean, as you say, you gave me a lot more detail than I've had previously on this situation that happened, and of course there was still a bus wall in front of the vehicle that feels like it should stop for, especially if your perception system is screaming that, yeah, it's right in front of us, it's gonna stop. And I'm just looking at velocity, I see a deceleration, it's gonna stop. So I don't know the technical details and why they've done those choices, but I would imagine that they have really good reasons for doing it, which still just shows how complex these situations are. That even a big company with lots of experts can still make these seemingly simple issues.
Well, it's true, of course, that you can't have false positives that make you brake for ghosts. Tesla does this, and many of its owners complain about it. But of course, you must never have false negatives and hit buses. And so you have to dial the trade-off between those two, and Cruise obviously is rethinking about how they did that. And hopefully now, by the way, speaking of the complexity of the problem, some, I thought, fairly good news for Cruise also came out, and for Waymo, also came out, because the San Francisco Transit Agency, known as Muni, isn't really a fan of the robotaxis in the city. It's tried to write letters suggesting they slow down their expansion. They don't have regulatory authority over them, so they have to play other games. But they decided to ask all of their drivers, please make note if anything funny happens while you're driving around on your buses and your streetcars with one of these self-driving vehicles. They're supposed to log that. And a news organization got a hold of the logs and wrote a story that I interpreted a completely opposite way, because their story was, look at some of these bad things that have happened, and indeed bad things have happened. But the most telling fact from the list was that in just over 6 months, they had logged only 12 incidents, with a lot of cars on the road traveling together, probably 1 million miles in that time. And I was struck by how low that number was. I was saying, wow, if they're, sometimes these vehicles are blocking the street. They do that because they have too much caution, actually. They don't know how to resolve a situation. They aren't confident enough in their remote assistance tool to get them out of the situation. So the vehicle is just sitting there with its flashers on, and sometimes blocking the bus or the streetcar and other traffic. But I take the following view, which is that I'm a booster of this technology. I believe it's going to be very valuable to society. I believe it's going to eventually reduce congestion, although self-driving cars don't do that on their own. They help contribute to tools that can do that. And while they're young and while they're in pilot projects and new, they are going to have rough edges and problems. Hopefully never as serious as hitting buses, but definitely as serious as getting stuck and blocking traffic. And they will do this when there's only a few of them on the road, because it's a pilot fleet, it's a test fleet, it's a few cars. Then they'll get good at it and they won't do it as much. And then there'll be 1 million cars on the road, and the 1 million cars will be improving traffic and saving lives. And the small number of cars will be blocking things a little bit. And that seems like a fantastic trade to me, especially if it's only 12 incidents in 6 months. There are more, by the way, than that, but that's what their drivers logged. We were starting to work, because we've been seeing a lot of reports in social media and other feeds about these incidents. And a lot of people have been wondering, boy, are these things just blocking traffic left and right? And so it turns out, no. When you do real data analysis, they're not. Yet everyone else, at least I shouldn't say everyone, but a lot of people have had the same reaction, saying, "Oh my God, these things are blocking traffic. Get them off the roads." And that kind of complaint will be made against the trucks that your company wants to put on the road. I mean, your trucks, of course, as big transport trucks, they're not a little Chevy Bolt. If they were to hit something, I mean, anything really, there could be something very serious about it, which is a challenge for you. This is actually one of the questions which always surprised me about doing trucking. And when people were first planning their self-driving efforts, everyone looked at trucking and said, okay, there's a commercial value proposition in trucking. It's very clearly commercial. You don't really have to debate the numbers very much and some of the other factors. But since you are going to have some crashes, you don't want to have them in big transports. So what made you decide to go the other way on that question?
I think our view of autonomy has always been that the way it's going to be rolled out in a big way is to start in very specific locations and situations where you can control the environment and where it's less dangerous to drive. And that means that you can reduce the complexity of what you need to do a whole lot, and you can make it a lot simpler to explain how the system is safe. So when we decided to go into trucking, what's great is obviously when you're trying to build your safety case and you know that there's no human to take into account. There's no human sitting in the back that wants you to drive aggressively because they want you to drive like a human does. And there's no person sitting in the front who's actually, driving the vehicle and being something you need to take into account in any dangerous situation. You know that your vehicle is totally humanless, and that means you can try to keep the rest of the road and every other road occupant safe rather than yourself. So that makes our safety case simpler. The other side of it is, as we're only moving freight, we right now are focusing on working with highly automated partners like General Electric Appliances, who has lots of automation inside the factories and lots of experience on the last 40 years of electric autonomous vehicles. But we've rather thought about our systems like adding that to the outside of those systems and trying to apply them on roads directly, which is a lot more complicated in a lot of ways, because as you say, severity is very high. But severity is very high at high speeds. So hence, we've started out with lower speeds where we can prove that we can remove the safety driver from early days and rather try to increase the complexity over time. Because that way we can build a larger fleet where we can still keep severity low because higher speeds aren't involved yet.
But hold on a minute. I mean, these trucks, even at 30 kilometers an hour, they can do a lot of damage where a Chevy Bolt wouldn't do very much at all.
They can, but the great benefit is we don't have to drive across an entire city. We'd rather try to drive very repetitive routes where we have high volume flows, which makes the situations a lot simpler to foresee than if you have to take care of an entire city in terms of operational design domain.
Well, it's definitely a simpler ODD problem set, and there's no question about that. But I don't know. I mean, I'm not that satisfied by your answer yet. I mean, I'm just hoping, of course, none of the trucking companies and many companies are trying that, and many of them are trying it on highways at 100 kilometers an hour or more. There's a huge amount of kinetic energy going on. It is a simpler environment, and I'm hoping that they don't make a mistake like Cruise made with the bus.
Yeah.
But unfortunately, such mistakes, as we can see, do happen. And I mean, my understanding of you guys now, I mean, those who haven't seen at least your prototype truck, might not know, but it's the most science fictional looking of the trucks because it doesn't have a driver position at all. It clearly can't fit a human being. Although that's not what you're deploying on most roads right now. Today you're using standard trucks that you've modified, but your goal is to deploy a truck like that with no room for anybody. Maybe it gets you a little more length to put the cargo in because European rules limit the length of the entire vehicle while American rules focus on the length of the trailer. So that can give you some minor benefit. But your focus, of course, is on these medium distance runs, which can be done with electricity. One thing I'm curious if you've studied is that I've seen a number of statistics about how diesel trucks are obviously disproportionately a major emitter in comparison to the gasoline cars. And so electrifying diesel transportation is one of the biggest wins out there in electrification, which is great. But diesel is also the great emitter of particulates. The World Health Organization estimated that particulate pollution kills something like 4 million people a year. It's COVID level, except it's every year, not just 1 year.
Exactly.
Do you have some figures on what you can do with particulates? Now, I think most particulates still come from coal power plants and factories and so on, but diesel trucks certainly do much more than cars. Have you studied that as part of your quest for electrification?
Yeah, I think we, of course, will be able to reduce that by a lot, especially inside cities where diesel trucks emit very dangerous levels of particulates. But even then, I mean, what we're trying to make sure in this transition is that we don't only look at the particular vehicles themselves, we look at the system and try to think about not replacing a truck by truck basis, but rather trying to look at the system and how we can ensure that we move all the goods we need with the available assets we have. Our customers, they want to go sustainable. They have a long-term commitment to get to sustainability, and right now it's really hard for them to get there. So I think foremost our focus is on that CO2 emission, but of course there's other side benefits for health. But I think we've mostly spoken about the CO2 emission as it's easier to talk about as people aren't as aware of all the particulates emissions. So it's a much easier story to explain, but for sure, there's going to be a lot of life saved if we can manage to also remove those particulates, which is a side benefit of going electric.
I mean, I don't think it's a side benefit. And one of the reasons I talk about it is that we unfortunately still have a large set of people in the world who are skeptics about greenhouse gases and global warming. But they're less likely to be skeptics about, they can be skeptics about particulate death, but it's much more immediate. I mean, this is your grandmother dying. This is not sea level rising in 30 years, which is much more abstract to a lot of people, and which is why we have a political argument. We don't really have a big political argument about whether particulate pollution is good or sulfur dioxide or the other emissions of diesel. So, because, which is what we're getting to, which is this interesting thing that is not immediately apparent in looking at your company, because at first you see the science fictional truck and you think, okay, this company is all about truck automation, and which of course you are very into, but you're even more into cleaning up truck emissions and using the fact that you can use electric trucks for medium haul routes of about 300 miles, even less right now, but eventually about 300 miles, which is within the range that you can get in a battery. Of course, it's always a problem. Batteries weigh a lot, and it's hard to do cross-country runs or go across the continent with battery.
But maybe talking about those constraints, because that's what it is. Even today, the freight system has a lot of constraints, but normally because of inefficiencies that we let be there, that we don't really do anything about. We don't really solve those constraints. We just work with having abundance in volume and in range and many other things. So when we think about electrification, what's really, really hard is that you have a range constraint, you have a charging constraint, you have a cost constraint right now. And if you can work around those constraints and use software to plan around them, you can go sustainable even today and change over your fleets. So, and that is what we're doing on a large way. So we've signed the largest deals for sustainable freight out there. And we're the largest customers of electric manned trucks out of the biggest OEMs out there, basically most of them. And those are the vehicles we're deploying both in Europe and in America in a really big way. And that's because it's urgent to start changing over to electric vehicles and to get the ball rolling. And I think people are still worrying about that the range isn't enough to electrify. But we want to tell a different story, that you shouldn't just think about waiting for the next truck. but rather think about how can I change the way of working to accommodate for this technology so I can get to those benefits of having a fuel that's cheaper than diesel, and that's going to be less of a risk long term, really, because in a lot of places we're seeing diesel prices increasing, especially in Europe from legislative reasons. But I think that's the same in some places in America as well. So I think it's becoming more of a risk, and also as electric technology proliferates, you're going to see that your residual value of a diesel truck is going to be lower. So I think people don't really realize the risk that's appearing when it comes to ICE vehicles in a commercial setting. So we want to make sure that we can deploy electric technology, both manned and unmanned, where it makes sense, and have a system that works for both, where we can really get to the benefits of electric in terms of maintenance and longevity of the vehicles, as well as the cost of electricity. So I think that's what we're trying to provide in a really big way.
Well, I mean, the total cost of ownership, obviously, you're forecasting should be much better in the electric truck over the diesel truck, if you're buying a new one at least. Of course, most people already own their diesel trucks, and so their math may be a little bit different on that. But the cost of electricity is actually going through some annoying increases. Hopefully, we'll see that reduced as time goes on, but certainly not here in California, where it's even at night, which it is here right now. It's part of my background. The cost is about 25 cents per kilowatt hour here, and California is paying more. And during the summer afternoon, it's over 50 American cents per kilowatt hour. But it's even more expensive if you want that electricity delivered at a megawatt. And this has been one of the challenges. So Tesla's semi-truck, for example, they hope to charge it with megawatt chargers. Many other electric truck companies are not necessarily looking at megawatts, but half a megawatt or something in that range. And it's expensive to deliver electricity that fast. You need expensive gear, and you also need a very high peak load service from your power company. And usually these power companies will charge you more on what your peak load is than what amount of electricity you use. So couldn't that hurt the economics of this if people all think they're going to recharge at a megawatt?
And I'm happy that you brought it up, because getting back to this, I said about constraints. This is yet another constraint. The grid won't be able to provide the electricity you need at any given point in time. So if you think about logistics, there hasn't really been any major innovation since the container was invented and brought out in a bigger way back in the 50s. And since then, we've been hoping for digitization to really take over the industry and remove all these efficiencies that's existed, but it hasn't. I think a lot of the pen and paper work has moved over to being in Excel instead, or some sort of sheet. But not really digitalized. And I think electrification is this opportunity to really starting to work with the constraints that exist. And the grid is yet another constraint that you need to think of in the system to make sure that you actually charge at the appropriate rate and for the time you need, and that you don't build too many chargers, because then if you have your own charger network, and you can get to a high utilization of that network, that's how you can get to a much lower cost than others out there. And I think that's one of the reasons why we think there'll be some consolidation in this industry, because you'll just have major benefits out of being able to run this at scale. And it's a bit different than previous technologies in that way. But this gets down to being able to work with all those constraints that exist around technology and use those to your advantage.
Well, let's look at a particular thing, because the other plan we have for the future for our electrical grid is that there's going to be a lot of solar on it. And that solar is going to be available from around 9 a.m. to around 3 p.m. It's going to be generated at 3 p.m., but then the rest of the market is going to want to pay a lot for it after 3 p.m. But it'll be very, very cheap between 9 a.m. and 3 p.m. So that's when everyone with an electric car is going to want to charge, which means, unfortunately, they won't be able to charge in their homes if they commute. They'll have to charge in offices and computer lots. But what about trucks? How are we going to charge trucks if we constrain the fact that electricity is going to cost, I think, like a tenth of what it'll cost at other times a day during those daytime periods when there's tons of spare solar power that nobody else wants?
I think there's many answers to it, of course, because as you also know, the future energy mix is
Sorry, I meant here in California. In Sweden, the sun doesn't actually shine, I think, for half the year. But
that's also very true. And yeah, we have a whole lot of hydropower over here.
so that's
But
better for
there's
charging. Yeah.
but there are similar challenges across Europe, and we have deployed already in several countries across Europe right now. And I think the electricity challenge is something that really needs solving, that we also know. But what's actually a benefit of heavy electric trucks is that when you do these deliveries and you work with your constraints, you will know in a very clear way when you're going to need that power. And when you have plannable consumption of power, you can do something about it. You can start thinking about how to use that power. Of course, there's still challenges around that, but it's a major benefit that you can store power. And of course, well, you have these huge batteries, which works two ways. And that means there is additional models we built on top of that. But overall, I think we're looking at all sorts of different energy solutions to be able to charge these vehicles. Because I think what you're still trying to alert to is that they will use a whole lot of energy, but it's also the most probable way this industry will play out. We think that hydrogen is not going to be better at solving this problem. We think that battery electric is the way to go, and we think that rather we need to solve these other problems around it anyways.
But I mean, I'm a fan of battery electric over hydrogen as well. But one question about battery electric that bothers me is that if you do want to get some good range, you're talking about a fifth of the weight of your truck belonging to battery or more. So that's a challenge in terms of both damage to the roads, which is done by heavy trucks almost exclusively, and it goes up with a fourth power of their weight. It's a challenge as far as you lose cargo capacity because you've got to carry all this battery material.
So there's many answers to that, of course, but foremost, right now, most of the customers we're deploying to, where we are again doing major deployments, we don't really have that issue with range. And why that is because we really work with the assets we have, and we try to use them in the most optimal way. And we try to not only think about one truck with one battery, we try to think about a system of vehicles with their own batteries in themselves. That we use in concert, basically, to move all the freight that we need in our system. And I think when you do that, you can even solve longer hauls, even with smaller batteries. Because I don't think the future is to bring the largest possible battery onto a vehicle and just move anything with that. I think it's about using all the resources in the system much smarter than today. Mm-hmm. Otherwise, it's really, really hard.
I mean, it's kind of funny. People who read me frequently will find it strange that I'm even going to mention trains, because I'm famously very skeptical of trains for passengers, and I think because people love them, and I think they're overrated. And yes, they're nicer in Europe than they are in the U.S., but Europeans still travel 82% of their kilometers in cars. But when it comes to freight, it's a different story. The cost per ton mile, the energy per ton mile of rail is really quite a lot less than even the electric trucks, and way less than the diesel trucks. But the speed and the flexibility are poor. Why isn't the answer to this just fix the speed and flexibility of rail?
Because that is super expensive historically. And I think that's the reason why you're seeing such proliferation of trucks, where the freight going on roads is just increasing rather than the other way around.
Yeah, I know.
But we think that trains is an important part in solving the emissions here as well. Obviously, in Europe, our trains are driven by electricity as well since a long time back. In America, you have a different situation with ranges and other things, so you use different fuels, but it's still a CO2-wise more efficient solution, even in America, I would assume. We think it's yet another part of the system that needs to be planned in concert with other assets in the system to get to something more efficient than today.
I mean, I've imagined, for example, if there were robotic mode transfer where containers could just be pulled off trains and get onto trucks with robots doing it, and very scheduled and short delays, and also, of course, better routing of the trains, better track control, so that the vehicles can get. Here in the U.S., they average, I think it's 23 miles an hour, 40 kilometers an hour or so, when they're crossing the country, which is not a speed that most shippers are interested in unless it's ore or grain or something like that, which is what you see on those trains. But their cost, again, per ton mile is so good. And that's why I would say, and cargo, cargo owners do care about convenience and speed, but not the way that people do for passenger traffic, which is why there's such a problem with getting passenger trains to work. Now, you're also planning on using tractor swap, is that right, in order to do the longer hauls?
Yes. So we're building out something we call grids, because as I was saying before, kind of the core of what the company is doing, our freight mobility platform Saga, is all about optimizing our assets that we have in the fleets. When we're building out our grids, the way we think we can solve longer haul is through a kind of Pony Express setup, where we use the fact that we have infrastructure built out with customers across geographies. And that way we can start moving freight longer haul. We can have people working in the vicinity of their homes, not being away from their families for long amounts of times. And that way we can also get down the cost of moving this freight for electric and get down to battery sizes, and also get up utilization of assets, as we can plan more efficiently with smaller units in a optimization system.
So okay.
I was just going to say it's a really important part of solving sustainable freight at scale.
So you're in Sweden, and you've been deploying in Europe. But generally, the trend in self-driving technology in the last few years has been Europe is a much slower place to get things done. So why Europe? Why are you there? I mean, other than maybe you began there, why are you doing a lot of your deployment there?
Well, simple reason. There's a few different things. We are deploying in both America and in Europe, but the difference maybe in Europe from other, let's say, technology approaches is in where we deploy these shorter hauls with our autonomy, where it's repetitive. That's actually something that works in Europe. While if we wanted to go on highways and do safety driver testing, that's something that's a lot harder in most countries in Europe. The one more part that that's actually interesting is that homologation in Europe is, of course, different to self-certification like you have in America, but it has moved a lot in the latest. And we're seeing that homologation is starting to get to a place where we can start seeing type approval in the future. I think before now, it's not really been that clear how that would all play out, but we're starting to kind of see how it will. And that's where we can start seeing type approved vehicles in Europe as well. And I think when it comes to autonomy, some of these safety ways of working and standards, I think will be similar globally, because it's one of these advanced technologies that is created on a global scale, even though deployment is, of course, a lot more frequent in America than most other places right now.
Yeah, I have to say my view of type approval is quite dim for this. I think both it creates this checklist that people just develop to, and it's bureaucracy based on old conventional wisdoms about how things should be done.
Sure.
And at the same time, I don't think it actually is all that great a way of certifying that something is safe. It checked the boxes. That's anyway, to my mind, it's there was a Dutch proposal that was a little bit better. It was to try and develop an analog to the driver's license, but it's still in very nascent form. And the American self-certification form shocks Europeans when they hear that that's how it's done in the United States. It even shocks Americans when they learn that the companies are certifying themselves. But I actually think it's more likely to be the right system if you basically just have to make sure you put the motivations in the right place so that everyone is motivated to serve the public interest. by serving their own interests. They are going to serve their own interests. You're never going to stop them from doing that. You just have to make sure you can align their interests with the public interest, and I think it's possible to do that. But this is why I think the United States has been leading the way in terms of the speed of innovation. The Chinese, of course, have yet another crazy system which can sometimes move much faster than either of the Western systems, but also sometimes move slower. So we'll see how that's going.
I think in the end, what's important is that you have a way of conveying how your system is safe to the public. And I think in America, some people are doing that. We have VSSAs, and we're seeing a lot of other ways people are trying to convey how their systems work and how you should reason about them. And I think the European system here is yet another way of doing that, I guess, with, as you say, a lot more bureaucracy, but at least it's a way of having the public looking at these systems and trying to dig a little bit deeper than just seeing, what you're seeing on the surface.
Yeah. Well, I mean, the way I put it to people is it's already illegal to hit things. We don't actually need a new law to say it's even more illegal to hit things. You just got to make sure that nobody decides I'm going to, hit a few things just because it's, I just pay the cost and go away. You want to make it so that they're motivated. Well, we'll see how that plays out. And China, United States, and Europe will all do things differently, and maybe they'll even compete with each other if they see things going. I mean, the Shanghai Auto Show is just starting. I'm sure there's going to be more surprising revelations in China, which I haven't been to in several years for obvious reasons. And so it's harder to figure out what's going on the ground. All right, so let's get back to we've been talking about your electrification, but what about the state of your automation? Today you mostly operate with safety drivers except on closed private roads, that's right?
So the way our setup works is we make this plan together with customers, sign long-term contracts, we deploy manned electric freight and autonomous electric freight. We don't have any manned vehicles that have autonomous systems on them. Those are electric vehicles that we use to move freight like normal trucks. But to the same customers, we also deploy these autonomous systems, and they are fully driverless. We have remote operators that don't have safety accountability, monitoring systems, handling operational smoothness, basically at customer sites, and supervising certain stretches of roads. But
so when you say the remote operators have no safety accountability, so they're not ever steering a remote steering wheel then, or are they?
So the only thing they can do is to remote assist vehicles, and that means doing minor adjustments at very, very low speeds. But the vehicle is still accountable because, of course, if you are remote operating something, that remote link can always go away at any moment. And that means that the vehicles always needs to be safe on its own. And that's the way we see it. But we think still that having a human-led autonomy where we still have humans monitoring these vehicles is super helpful, both for adoption because when you're working in a logistics environments, there's a lot of people moving and there's a lot of things happening, and that's helped us a whole lot.
Yeah, no, well, later today, but after this or before this will show up on YouTube, I'm doing a program particularly about remote monitoring and remote operation. And there are a lot of different ways that people do remote operation, ranging from, 100%. Driver radio controlled car over the data networks to just watching it or giving it strategic advice. But you sit entirely in the strategic advice part of it. The remote driver cannot, or can they effectively physically grab a virtual wheel? Or is it only they say, here are some waypoints, please make these maneuvers?
So they can move the vehicles in very slow speeds, but only for assisting. So that's minor movements, and all perception systems are still running on the vehicle and these things. But so that's kind of our mix, but that is still a strategic advice. It's a bit different from sending points, but not really that different. There's always many nuances to it.
So this would show up in like a loading dock, a freight yard, that kind of thing? They would do the low-speed operation?
Yeah, or if you have some situation where vehicle is standing still for whatever reason on the road, and you can always say that there is a possibility for a remote operator to move the vehicle in such a situation. And that means that when we're deploying, it makes it simpler to explain how we'll handle these types of situations because we can. And I think that's the most important bit.
And these are existing trucks that you have modified. How many of your special trucks with no cab are you deploying in this way?
So these are not modified. It's not retrofits. So we think that when you're building a autonomous system, you need to have hardware that's through and through made for autonomy, so that you have redundancies built into both steering actuation, braking systems, power redundancy, and other subsystems that's on board. Because if you look at most trucks today, or well, all trucks, they are built for having a human in them. That's what they were made for, and every system is geared towards that. And that means that you have a whole lot of single point failures. Well, you know this, but that's something we've taken into account since early days. And the vehicles we're building, those have redundancies like that built in, and we use the particular motion dynamics of those low-level components when we're building our motion planning systems and kind of safety critical layers and whatnot.
Yeah, no, I'm in the early days of the business when people were first modifying cars, and everyone started, of course, by modifying stock vehicles, and we ran into the problem that you just described, that the human being is the backup for many of the systems in a car. The thing that saved that was that actually the arrival of hybrid cars and electric cars ended up putting the redundant systems into those vehicles. The electric cars tend to have an electrically actuated parking brake and a separate electrically actuated braking system. They didn't tend to have two steering motor systems, but it wasn't too hard to modify them to have that. So today, of course, yes, people are putting in these redundancies. But in trucks, you're saying there just aren't any trucks that have those redundancies, and so you need to put them in
normally
a custom vehicle.
What most companies do, I think, is to add redundant steering motors to the actual
column, yes.
Yeah, to the driving column, exactly. And what you still have is a single point of failure in the hydraulic motor. And then there's basically a calculation done where you say, well, that doesn't happen very often, so that's fine. But that's probably not going to be fine forever, especially if we go into some larger scale, that's going to be a problem. And there's not only that system, there's also others deeper down. But
you can do a limited amount of emergency steering with differential braking on the wheels if you have different.
There is a bunch of ways, but you get particular performance from it. And I think the question that you got to ask is that performance enough? Will it solve the problems you need to solve? And especially at these high speeds. And as you were alluding to earlier, that the severity of accidents are very, very high when you move these heavy vehicles. So having high performance system that can handle more than enough what you need, I think simplifies the safety case greatly, because then you know what the system can handle and can't.
So the other companies, Aurora, Waymo Via, Too Simple, Plus, and so on, they're all modifying existing trucks, and they're operating them on highways today with safety drivers in them. Sometimes they're doing demonstration runs with nobody in them. So they're having to do a lot of work to modify these trucks to give them the safety reliability that is necessary. You are sticking strictly to your own custom built, but it's hard for a small company to custom build a whole brand new vehicle. So that must have been a difficult choice.
It is, but a few things. We've said that for autonomy, we haven't really seen a platform or an OEM that's moving towards the type of platform that we need. Because if you look at electric autonomous systems, it is a much simpler platform, because when you go electric, you of course know you remove a whole lot of moving parts and you simplify the build of the system. When you go cabless, you also remove a whole lot of systems that's normally on there. It's about 60% of the complexity if you count in both the mechanical complexity as well as everything designed for the driver in terms of safety and these things. So that means that building something is a lot simpler. And when you look at electrical actuators that exist, you're not going to see those in your diesel trucks for quite some time. Because when you think about building a truck today, one given model can have 10,000 variations. And then on top of that, you're adding an electric drivetrain and battery systems that they could modify into this platform that already has 10,000 variations. And then on top of that, you're adding in all the redundancies necessary to move this vehicle in the correct way. And that's meant that if you look at the timelines of some of the OEMs, they have promised to build vehicles like this, and that's what Aurora and I hope most of the industry is relying on, that you will get these fully redundant autonomy-ready vehicles. I think the issue there is maybe, is it compatible with the way your safety case is built out when you have two separate ways of building this out? And also, OEMs is trying to fit this into something that's already very, very complicated. That means adding these redundancies across everything makes it super complicated to build something that's actually good enough.
So let's talk about business a little bit. Now, the current trucking business is mostly done by owner-operators or very small trucking firms that own just a few trucks. But you obviously want to have a fleet business where you or a leasing company own all the truck and you operate them all. And of course, there are not operators other than the remote operations team, which will be your employees rather than owner-operators. So that's a pretty big shift in the economics of trucking and shipping. How do you pull that off?
I think, so far it is a little bit different in Europe and America, but
yeah, sorry, that's an American statistic about the owner-operators.
For sure. And it's also very true in Europe as well. We have similar things here, but we've seen great success in America with these deployments that we've done. As you say, about 87%, I think, of all the trucks are driven by owner operators in America. And it's a very fragmented market where I think the largest carrier has about 1% of the market of this $700-800 billion a year market. But for us, it's been really, really important to be able to control the assets in the way that we need very particular data out of these electric vehicles to be able to work with the constraints. We need to understand our chargers to a very deep degree. So we're deploying software to those as well in order to collect all data into our platforms. Because the way we've seen it, if you want to build a bespoke vehicle, again, which we think is necessary, you're going to need volumes in order to make that economical. Hence, we've built large fleets. We're deploying into thousands of vehicles eventually, even with manned electric trucks in the near term. And that will mean we have signed contracts with customers that are large, that are global, that has the muscles to utilize these, autonomous technology where it's appropriate to deploy it. And I think that's the way we go to market and the way we fund autonomous electric vehicles in itself.
So you'll be able to get all that. It's just a lot of capital compared to most.
It is a lot of capital, but we also see that large companies that want to make the transition into sustainability, there's a lot of capital investments that's necessary. And I think we want to make it super simple. We create a turnkey solution for these customers where we include financing, we include charging, vehicles, drivers, planning systems, connectivity, everything that's necessary in order to run a fleet like this. And when we speak electric around these constraints, it's possible to run a small electric fleet using pen and paper methods where you just replace diesel trucks one-to-one with electric. But as soon as you start to get above 5 and 10, or maybe even 20, that's maybe how far you can go with the traditional methods. That's when you really, really need the software to be able to plan it out. So we think that we need to tie this system together. It can't be fragmented if we're going to work with these constraints. And you need data on a deep level from every part of the system and tie it all together into just one loop. While I think historically we had optimization loops in different subsystems, if it's the TMS or if it's the onboard vehicle optimization for driving, or if it's some other system. There's been sub-loops optimization, but what we need at this point is much more integrated data approach to solve and work with all these constraints that exist in the system.
So that means there won't be too many winners. You're saying the economies of scale are going to be quite strong.
We think that yes, that's how electric will need to work in order to be efficient. And eventually, sure, like unit economics will mean that electric will be cheaper over time. We see that in electric passenger vehicle cars, and we think that's going to be the case for heavy electric trucks as well in a bit of time.
Well,
And
actually, between you and me and the YouTube audience, um, how much do these companies really care about sustainability? Are they doing this because they really care about sustainability? Are they doing this because they want to look good and check some boxes on ESG, or is it the cost saving is winning them over and they don't need to get green is down the list?
no, I think that's been the case previously. When we started out, we had a whole bunch of companies who were saying, let's do this. Let's deploy 5 trucks. And we're like, okay, but that's mostly greenwashing, we would say. So if you want to work with us, you need to be serious. So what we're doing now is we're taking over major parts of all the freight that some of our customers have. And that means that we get all this data, we get all these assets working on one system. And that's when you really can get the benefits out of electric, because otherwise it's really, really hard. So I'd say it's no longer this type of small time thing where you're doing it for marketing, but it's a real deal, major commitment, deployment, where companies are serious about reaching and spending to reach their sustainability goals long term.
Well, that sounds good. I mean, although we all know about the driver shortage, which means that there's not really going to be a lot of jobs lost to this. Last week, the Teamsters Union in the United States started lobbying against trucks being able to run without people in them. Do you think there's going to be a big political problem about that? It could be worse in Europe. I mean, in Europe, jobs are even a bigger political deal than they are in the U.S.
I think the driver shortage will just get worse and worse and worse. And sure, that will mean great wages for drivers, but I think if we go back to the topic of sustainability, we need automation to have a sustainable society in this, I think. There will always be a whole lot of work for human drivers, even if we, make people more excited about the work. But the fact is, we don't have enough people to do all the work that's necessary. We see that all across the Western world. And I think automation is one of these necessary tools that also makes it possible to get data on a more precise level so that we can plan and use our assets much more efficiently than today. And that is necessary to really get to a more sustainable society.
Well, that's a rational argument. The political jobs debate won't necessarily be about rational arguments, but we'll see how that goes. Now, in cars, most people are aiming for safety levels that match human levels, which means one sort of modest crash every 500,000 miles, 800,000 kilometers. Yeah. What are you aiming for in trucks? And how far are you along in getting it?
I think autonomy in general, it's better to view it as a new type of vehicle, because it shouldn't be compared one-to-one to humans. I think that's historically been the case sometimes, but I think as these systems mature, that's no longer the case. People are looking at them as a new type of system where if you have a flaw in one vehicle, that means all your vehicles out there have the same flaw. And that means it's more similar to maybe how the airline industry aircraft industry has worked for some years than how passenger vehicles works. Because if you look at the airline industry,
their safety record is very, very good, and I'm not sure that can be attained in ground vehicles for quite some time.
Well, I think in a Swedish context, we've had this zero vision for death in traffic for many years.
I know.
But I think it's pretty apparent that if you want to reach a vision of zero death in traffic, automation is the way to go there. There will never be zero, probably, but it's always going to be a vision. And I think if you want to get close to it, even remotely close, you're going to need a whole lot of automation. So in that
I
way,
actually make the joke that vision zero isn't enough, because with good enough automation, there'll be people who are being created in traffic. And so you'll have negative.
Never heard that joke before, but that's
negative
kind of funny.
Numbers. But seriously, people are going to be more critical of trucks. The number of matching human performance with cars is basically revolves around the idea that the companies don't want to, the public doesn't want the companies to create more risk than having human drivers out there creates. Zero risk doesn't seem attainable. It's a nice goal, but it doesn't seem like it's the right goal for some time. And so people saying, look, if we can be at similar safety level to humans, well, then deploying our vehicles isn't creating any more risk. It's not creating zero risk, but it isn't creating any more. But I've been wondering if people will think the same way about trucks, and that's what I was feeling. You're worrying, or you're suggesting to me that people might treat trucks like airplanes and say they have to have an almost perfect record.
I think they will eventually, but we also have to remember that when airplanes initially came out in a more commercial setting, it was for sure another time back in the, let's say, 60s when you had commercial airplane in a much larger sense.
Yeah.
But since then, it's moved step by step, going towards more and more automation, and to some extent also standards being built out to think about reasonable safety. There will still be airline crashes, but I think what I rather want to get to is that over time, they've decreased the risk, improved the reliability of the system, that's the way you go to a much safer tomorrow, I think, where you can have a lot less issues in traffic than today. So there will always just be the question of what is reasonable risk in the end, because that's the estimation you're doing when you're building out your safety case. So why do I need these redundancies? Well, that's because a single system will fail. And if you have many systems doing the same thing, that means you will have less failures. Yeah. And then it's down to what is a reasonable amount of safety. But I think comparing it to humans is sure, it's some kind of measurement, but it's probably not going to be what you look at when you're really starting to see these systems on a really large scale, because then it's an automation system that will work with other metrics than looking at what humans are doing.
All right. Well, I mean, best of success to you, of course. Unlike many of the other trucking companies, you've actually been successfully raising money while the rest have seen their SPAC valuations not go in the direction they want. And we saw very sad news for Embark recently. And we hopefully won't see too many of those happen. But the truth is we probably will. Consolidation and competition are the way of things, especially when the market gets into downturns. But let's hope we see great things from Einride. If you have any other final comment, let me go ahead. Otherwise, we'll sign off for this, and we'll no doubt hear more from you guys in the future.
I gotta say, it's been great speaking to you. Lots of questions around the safety aspects, and I think back in the early days of our company, at least, when we were talking about safety, people weren't that interested in that. And I think for us, it's any sort of commercial interaction means that you have your safety case in order, and that you have a way of speaking and conveying your the way you think about safety and the way you built your system in a safe way in all the details. I think for way too long, ADS systems, automated driving systems, have been treated like a black box that will just do a bunch of things like a human is. And I think we're starting to really move away from that, which I think is positive, and hopefully going back to talking about what is your system safety, and more traditional safety works has always been the way you build automated systems.
All right, it's good to know somebody enjoys reading those safety plans and reports, because I got to admit they're sometimes a bit dry reading. But it is important that people think about those things. All right. Well, Tomas, thank you very much for coming in, and we'll see you again. And tune in, well, not exactly next week. We don't keep a fixed schedule for the next interview on the Robocars.com podcast. I'm Brad Templeton.